we have basically used the unit circle to answer sine and cosine. And we've used the unit circle to take the sine and cosine and answer by the angle, right? So if I said, well, the sine is 1/2, what's the angle? You would say 30 degrees or pi over 6, okay? So what we're doing now is we're having equations, and we are going to get that the sine equals something, and then you're going to have to tell me what angles correspond to that sine. All right, so the goal of this is to basically solve an equation just like you would if you were solving for a variable, which is really what you're doing. The variable happens to be inside of a trig function, but your goal is just like any other goal in solving an algebraic equation is to get the variable by itself, okay? So if I were looking at this particular equation, I would say, well, I need all my numbers that don't have trig functions on one side, and I need all my trig functions on the other side, just like you were thinking about solving an equation. So what I would do is I would move all of my trig functions over to the one side and all of my numbers over to the other. And so that's what we're going to do. We're going to take this 2 tangent of x minus the square root of 3 equals tangent of x. And so I'm going to subtract this tangent of x from both sides. And just like anything else, you line it up with the like term, so to speak. And then I am going to add the square root of 3 to both sides, okay? And when I do that, on this side here, I have 2 tangents minus 1 tangent. How many tangents do I have? 1 tangent, all right? The square root of 3, negative and positive cancel. On the right-hand side, the tangent and the negative tangent cancel, and I have just the square root of 3. Think of it this way. Anytime you are given the trig function and you want the angle, what do? It's the inverse trig, okay? So I need the inverse tangent. So if they gave me, hey, the tangent equals the square root of 3, what is the angle? So what they're really saying is what angle has a tangent that equals the square root of 3. That's what they're asking, all right? And so you're going to look on your unit circle and you're going to say, okay, I need square root of 3 on top. So that means my sine value probably has a square root of 3 on top, right? So what angle has a sine value that has a square root of 3 on top? Look at your unit circle at pi over 3, and let's see if it fits what they're asking for. Does the tangent of pi over 3 equal the square root of 3? That's what we want to know, because we're saying we think it's pi over 3. All right? So what's this? Tangent is sine over cosine, yes? What's the sine of pi over 3? Thank you. That was helpful. What's the cosine of pi over 3? 1/2.
Oh, yes.
All right. How do I solve something like this? Keep change flip. So square root of 3 over 2 times 2 over 1 equals, lo and behold, square root of 3. All right. So that means the answer to this equation right here, x must equal pi over 3.
Whoa.
I am simply trying to figure out what angle gives me that trig function. Okay? What angle gives me that trig function? So you want to get the trig function all by itself, and then you want to look at your unit circle and say, okay, which angle answers this question? Now, I will say that in your book, they have pi over 3 plus n times pi. They do that because this is a cycle, right? If you look at it, you're going to have pi over 3, but then you're going to have across the way, you have another one that also gives you the same one, right? If you look at the third quadrant, right, you have 4 pi over 3. 4 pi over 3 would also give you a tangent of square root of 3, would it not? Mm-hmm. But what I want you to do when you're answering these is I just want you to answer it like we did when we were finding inverse functions. Remember, for sine and tangent, give me the positive or negative angle in the first or fourth quadrant. For cosine, just worry about the first and second quadrant, right? Because that's all of them positive and negative combined. Does that make sense? So think about when you had to answer the inverse trig functions and you were given the trig function and I wanted the angle. For tangent and sine, you said, oh, first quadrant or fourth quadrant. For cosine, you said first or second quadrant. Okay? When I do this one, I want to move the 2 sine over. I'm going to do that by subtraction. When I do that, it cancels over here, and I have 4 minus 2, so I have 2 sine x here. I have just a square root of 2 here. I need to divide both sides by that 2, which cancels here. So my sine of x is going to equal the square root of 2 over 2. In the first and fourth quadrant, there is only one angle that gives you a sine value, square root of 2 over 2. Remember, your sine value is your y value, right? So what angle gives you?
45.
Yeah, 45. And in radians, it would be pi over 4. So x equals pi over 4 or 45 degrees. I will take either one of those. All right, my goal is to get my trig function by itself. What's my first thing to do here? Yeah, I'm going to subtract the 1. Just like think of an algebra equation. You would subtract the 1, you would divide by 4, right? And so that's what we're going to do. We are going to subtract our 1. That's going to give us 4. Sine squared of x equals 3. Divide by 4. That's going to give us sine squared of x equals 3/4. I don't want sine squared. I want sine. How do I get rid of a squared in any algebra equation? Square root it, right? So square root this side, square root that side. On the left-hand side, I have my sine x. On the right-hand side, when I take a square root with a variable involved, I have to consider the positive and negative root, okay? All right, so I have to consider the positive and negative root. 3 does not have a root, not a rational one at least. So we're going to leave that as the square root of 3. 4 does have a perfect root. It is 2. All right, so now I have to find 2 angles. I need the angle that gives me the square root of 3 over 2. I also need the angle that gives me negative square root of 3 over 2. Now here's the deal. With sine, I will take positive, negative. All right? So whatever positive angle gives you square root of 3 over 2, I will take negative angle. All right? The only time that I won't take it is if I say from 0 to 2 pi. And then I want you to list every angle that tells me that. Okay? And so we will get to that point. But right now, I just want you to figure out what they are. Okay? So square root of 3 over 2 is going to give me what in the first quadrant? Sine has to be positive in the first quadrant. So this first one is going to give me, yeah, pi over 3. Pi over 3, all right? Which means in the fourth quadrant, I would take, unless it says from 0 to 2 pi, which I don't think it does, I would take negative pi over 3. All right? Or the other one you could have is 5 pi over 3, yes. This is the same.
So you're saying the only time you would
those are the same.
take that as
if I said from 0 to 2 pi, then I want all positive. So I would want pi over 3 and 5 pi over 3, yes. All right. If I don't tell you that, you could say pi over 3, negative pi over 3, or you could say pi over 3, 5 pi over 3. I would take either of those. If I did not specify it, I would take both of those as answers. So let's look at these instructions. Find all solutions of the equation on the interval 0 to 2 pi. So this is no longer just, okay, whatever ones exist. They specifically want from 0 to 2 pi, okay? So from 0 to 2 pi means that I need to just go around one complete circle, and anytime it happens, list it. Meaning I can't do negative pi over 4. That's not within this interval. Negative pi over 4 is outside of 0 to 2 pi. All right? I'm also not going to list 45 degrees because they clearly want radians from 0 to 2 pi, okay? So here I'm going to say, where on the entire circle does this happen? List every single time it happens, all right? And so you could have 4 answers potentially. If it's something like positive or negative 1, well, if I had listed all 4 times that happened, I would have listed every pi over 4 on the unit circle, right? And so that's what you're going to be doing here differently. Your interval is very, very specific here. From 0 to 2 pi. From 0 to 2 pi. You'll notice it is inclusive of 0 and not inclusive of 2 pi. The reason for that is 0 and 2 pi are coterminal angles, meaning they will have the same sine and cosine values. So you would be listing them twice if it ever fell on 0. So like 0 has a cosine of positive 1. Well, so does 2 pi. So there's no reason to list 0 and 2 pi. They're basically the same angle. So it includes 0, it does not include 2 pi. So let's look at this first one here. This first one's a little bit different because it looks like we don't have any numbers to get on one side. The truth is, if we get everything to one side, it will be equal to 0. And if you recall your quadratics, all right, you could get everything to one side and factor, and then set each factor equal to 0, right? Does that ring a bell? So if I had something like let's not write that. So let's x squared plus 5x plus 6, something like that. And that equals 0. You would say, oh, well, that's x plus 2, x plus 3 equals 0. And then each one of these equals 0, and then I can solve. So that's basically conceptually what you're going to do here. You're going to put everything to one side, and then you're going to factor and solve. All right? And so this is solving by factoring. So let's look at this first one. For this first one, I'm going to want to move that 3 cosine of x over. So I'm just going to subtract that from both sides. And so on the left-hand side, I have the cosine of x sine of x minus 3 cosine of x equals 0. What can I factor out of both of those groups? What do they have in common? Yeah, that cosine. So I can take that cosine out. And I am left with sine of x minus 3. Everybody see that? All right. So just like in the other thing, I can set each piece equal to that 0 and solve them individually. Okay? So I can take this first piece, cosine of x, that factor, and set it equal to 0. And I can set this factor equal to 0. And then I can solve them individually. So then I'm going to look and say, well, where on the unit circle for the entire circle do I have a cosine that is 0? Where do I have a cosine that is 0? What angles give me a cosine that is 0? Right, and in terms of radians, it would be pi over 2, right? And 3 pi over 2. It should be 90 and 270, right? That's where my x's are 0, right? Top and bottom of that unit circle. So then I'm going to do the same thing over here. I add the 3 over, and I have sine of x equals 3. Where do I ever have a sine of x equal to 3? This is actually outside. Sine is always going to be between positive 1 and negative 1. This does not have an answer. So this does not exist. I don't have an answer to that because there is no angle that answers that question, which means these are my only answers. So this tends to throw people off. They don't like these. But all they're doing is factoring a trinomial, all right? You're basically looking for factors of 2 that subtract to give you 1. That's 1 and 2. Right? But let's think about it. If you had something like this, you wouldn't be quite as scared of it, right? You would say, oh, well, that's going to be x squared plus 2 and x squared minus 1. Factors of 2 that add up to 1, right? I mean, that's how you would do that. So now you're just going to do that with the cosines. All right, we're just going to do that process with the cosines. So I'm going to say, well, it's cosine squared of x plus 2 and cosine squared of x minus 1 equals 0. And then I'm going to set each one of those equal to 0. All right? So let's set this first one equal to 0. Cosine squared of x plus 2 equals 0. Subtract 2. Cosine squared of x equals negative 2. Take the square root of both sides. Cosine of x equals the positive or negative square root of negative 2. I have a slight problem here. Yeah, we're talking about real numbers only. All right, that would be an imaginary number. It's not happening on the unit circle. So this produces no answers. That one produces no answers. So let's look at the other one. Cosine squared of x minus 1 equals 0. So cosine squared of x equals 1. Square root both sides. Cosine of x equals positive and negative 1. This will give me an answer. All right. So we're saying, where does the cosine of x equal 1? And where does the cosine of x equal negative 1? Yeah, so look on your unit circle. There's one place where it equals 1. Where does your x value equal 1 on your unit circle? On your unit circle, where does your x value equal 1?
0.
At 0. So that's my first answer. Where does it equal negative 1? At pi. Those are my two answers. All right, so let's look at this guy. This guy's already set equal to 0. That's beautiful, but I have a slight problem here. I cannot factor it because I have squared 1 and 1. That's fine if that were sine squared, sine and negative 1, right? And then I could maybe do something. But I have cosine squared and then sine, and so we have some issues. If those were being multiplied together or something where I could get it apart, it's not. And so when you have something like this, you may have to rewrite it so that you have all of the same trig. All right? And so this should stand out a little bit. Cosine squared. Anytime you see a trig function squared, what does it make you think of at this point in your life? Okay. So we have a Pythagorean identity that deals with a cosine squared. It looks like this. Not plus, equals 1. All right. So if I want to get rid of that cosine squared, I can say, well, get cosine squared by itself. So cosine squared equals 1 minus sine squared. Everybody agree with that based on that Pythagorean identity, right? So I am going to take this guy out and replace him with that. So I'm going to rewrite this, and I'm going to say 2, and instead of cosine squared, I'm going to replace it with 1 minus sine squared of x minus the sine of x minus 1 equals 0. All right, and then we're just simplifying here, okay? I'm going to distribute, so I have 2 minus sine squared of x minus sine of x minus 1 equals 0. I can combine that 2 and that minus 1, right? So when I do that, I have negative sine, no, that's a 2, sorry, negative 2 to not distribute. Oh, we got to distribute here. Negative 2 sine squared of x minus the sine of x, and then 2 minus 1 is just 1. All right? Now let me be honest. I do not like factoring when I have a negative in front. It's not my favorite. So I take a negative out of everything. All right? I take a negative 1 out of absolutely everything. I divide everything by negative 1. This equals 0 divided by negative 1. Just divide a negative 1 out. He disappears, okay? And so that changes my signs. So I have 2 sine squared of x plus sine of x minus 1 equals 0. So factors of, basically I have to consider my factors of 2 that add up to 1, but now the 2's in front of my sign. So I can still factor this guy. He factors like this. We have 2 sine of x, and I'm going to say that is minus 1, and then sine of x plus 1. 2 times 1 is sine squared. Negative 1 and positive 1 give me the negative 1. Positive sign and the negative sign give me the positive sign in the center. So you're just factoring it. Don't let the factoring throw you off, by the way. Once it's factored, set each one equal to 0. Chop, chop. All right, so 2 sine of x minus 1 equals 0. And sine of x plus 1 equals 0. Set each factor equal to 0. So this one, add 1, divide by 2. Sine of x equals 1/2. Here, subtract 1. Sine of x equals negative 1. Everywhere on the unit circle where those two things happen for y. For y. All right? So there's 2 places that your y value is 1/2. What are those 2 places? Where are the 2 places on the unit circle where your y value is 1/2? There's 2 places where it's positive 1/2. 2 places. Pi over 6, right? Does that give you a y of 1/2? And then 5 pi over 6. Everybody agree with that? All right. There is 1 place where your y value is negative 1. Where on the unit circle is your y value negative 1? Y value negative 1?
3 pi over 2.
There we go, 3 pi over 2. Those are your 3 answers right there. So there are times when you might have to use, especially when you see a squared, you may want to look at Pythagorean identities and see if you can replace it and make it easier. Okay?
We're going to have a word